Alright, so after graphing lines, we're going to talk about graphing exponential functions. So exponential functions we've already solved. They're a function with x in the exponent spot. So to graph an exponential function, it's important to remember the steps. So step 1, get y by itself. Most of the ones that you're going to be graphing, the y will already be by itself. You're not going to be asked to solve for it. Step 2, make an xy chart by selecting values for x and plugging them into the function. So you can do this with a linear graph as well, but you definitely need to do it with a exponential. So for this unit, you're going to start with -2, -1, 0, 1, and 2 as your x values. Now, a special note, as we get into more advanced graphing exponentials, if you see a number and then the exponential has a plus or a minus, so it's x plus 1 is the exponent, you would put the opposite of the number being added to the middle of the xy chart. So instead of 0 for an x plus 1 as the exponent, it would be -1 in the middle. We'll get into more about that as we move on, but for the most part, you're going to start, you need to remember to start with -2, -1, 0, 1, and 2 as the x values and plug them into your function. Once you plug them in, you're going to have x and y dot points, and you're going to actually plot the points and connect the dots. So things to know about the exponentials is that the graphs will look like this. It'll look like a bent line, and it's going to get closer and closer to some number. In this case, it's getting closer and closer to y equals 0, or to the x-axis, and that they will have a horizontal asymptote at y equals, and it depends on where it's graphed. If this whole picture were moved up or down, the y equals value would change. So this one is y equals 0, because the x-axis is where y will always equal 0. So let's do an example. I have an exponential function right here with y equals 2 to the x power plus 4. So step 1, get y by itself. Check, that's been done. Step 2, create an xy chart. So here I use my -2, -1, 0, 1, and 2. I plug them all in. So 2 to the -2 power plus 4 is the same thing as 1/4 plus 4, 4 1/4. And I plug them in one at a time. You can plug them into your calculator and it would pop out this number for you. Alright, so my points are -2 and 4 1/4, -1, 4 1/2, 0, 5, 1, 6, and 2, 8. So step 3, I'm going to plot the points and connect the dots. So here was my 4 1/4, 4 1/2, 5, 6, and 8. So the graph is the right shape, so that's good. I know I'm on the right track. The graph approaches y equals 4, that pink line right there, but never ever touches it. That is an asymptote. Okay? So although exponential functions are often used in word problems, there's rarely any translation used. So the formulas are given as part of the problem. That's the next thing we're going to do after graphing. So here's an example of a word problem. Using the exponential growth model, y equals a times 1 plus r to the t power, where a is the initial amount, r is the percent increase expressed as a decimal, and t is time. Write a model to find the value after 5 years of a baseball card that initially cost $300 and is expected to increase by 4.5% per year. So let's pull the definition of the variables out of the problem. So where are my variables? If I look up here in my formula, I see some variables. I have a, r, and t. And right here it says a is the initial amount. So I'm writing down here a is the initial amount. R is the percent as a decimal. R is the percent increase as a decimal. And T is the time. So T is time. So now I'm going to go to the next sentence and look at the information that they gave us and put the values into the variables. Card initially cost $300. That's A, because that's the initial amount, and I know that number is going to be 300. And it says increase at a 4.5%. So that's our rate. So R is going to equal 4.5%, but I need to mark it as a decimal. And the way I make a decimal is I move the decimal place 2 spots, and R equals 0.045. Then I have my value after 5 years. So that's, years is a time unit. So I know that T is going to equal time, or 5 years. So again, I'll rewrite my formula. Y equals A times 1 plus R to the T power. I'm going to plug in my A, R, and T. I'm going to use the calculator to do what's in parentheses first, then my exponents, then my multiplication, and I know that the card is going to be worth about $374 after 5 years.